just change the directory onto that directory. Okay, now in here, what we're going to do is create a Python virtual environment. This will help us by keeping all of our projects separate, so each virtual environment is completely separate from the others, meaning that we can have multiple projects in the same machine, each of them using their own Python packages, and they will not cause conflicts with each other. So again, first go into your Unity project directory, and then in here, we're going to type the command python -m. -m means we're going to run a module. And the one we want to run is called VNV to create a virtual environment. And then afterwards, this requires a folder name where the environment will be created. So just keep things nice and organized and give it the exact same name. So just VNV. So this will create the virtual environment inside a folder named command python -m VNV. Now, if you're on Linux or Mac, the commands are slightly different, so check the official docs. And again, like I said previously, if you have the issue with Python not running when you type Python, then here instead of Python, just type py -m VNV VNV. So go ahead, hit on enter, and yep, now it's creating the virtual environment. Alright, it's done, and you can verify that it worked by opening up your File Explorer, and yep, over here there's a folder called VNV. And over there we have our virtual environment. Over here you see some folders, and you see this one with a bunch of scripts, and here we see a activate script. This is how we're actually going to activate the virtual environment. So back in the command line, we go inside the VNV folder, we access the scripts folder, and then run the activate. So when you do, yep, the command prompt changes. Over there it says VNV, so we are now inside the Python virtual environment. So any changes that you make here will not impact any other Python projects you have in your machine, like for example any other Unity projects with other Python libraries. Now before we install our Python packages, let's make sure our installer is updated. The Python package installer is named pip. So in order to make sure that it's using the latest version, let's run the command python -m. We're going to do a pip install -- upgrade, and we're going to want to upgrade our pip package. So just go ahead, hit on enter. And yep, now it's successfully installed the latest pip package. Okay, so far so good. Now we can begin installing our packages, and the first one we're going to need is a package called PyTorch. This is an open source library for performing computations using data flow graphs, so it's the underlying representation of the deep learning models. For that, let's run the command pip install, and here we need a specific version. So here it is, install Torch version 1.7 and download it from this website. Now if you have issues or you're watching this many months in the future, check the GitHub installation docs to see which version to use. So you go ahead, run this. And now we You wait for it to complete. Okay, PyTorch is now installed. Next up, we install the ML Agents package. So just do pip install ML Agents. However, just running like this may give you some compatibility errors. So let's try it and see. And yep, here we see an error where we have the incorrect NumPy version, so it's incompatible. So if you didn't get that error, then it's fine, just keep going. But if you did get the error just like I did, then the slash resolver. Correct version and installing the code was correctly installed by running the command, go into ml agents-learn, and then use the command --help and hit enter. And yep, if everything went correctly, verify that the ML Agents package was correctly installed by running the command, go into ml agents-learn, and then use the command --help. And hit enter. And yep, if everything went correctly, then you should be able to see the help files for the ML Agents Learn package. So here it is, everything went correctly, so everything is installed correctly. And as of the time of this recording, I'm using ML Agents Release 10 with the Python package 0.22. So again, if you have any issues or you're watching this many months in the future, check the official docs for any version changes. Okay, so far so good. And with that, the Python side is all installed correctly. Now there's actually one more optional step here. If you look in the console, you might be seeing some warning messages. Now, these are not directly related to the ML Agents package, but rather it's due to one of the dependencies. So if you're watching this in the future with another ML Agents release, it might not show these warnings. Something saying it could not load a dynamic library with the name CUDA RT64_101. So if you see something like that, it's telling you that it cannot find the CUDA libraries. Now, this is optional, everything will run just fine without them. So if you have no GPU, you can skip this step and it will use your CPU instead of your GPU. But if you do have an NVIDIA GPU, you can optionally install CUDA. So if you see that message, pay attention to the name of the missing library. So in my case, I was seeing a missing library, version 10. Again, pay attention. However, the missing library is version to the after install. If you run that again, however, you might be seeing another warning, which again, check the library name. So you might be seeing another missing library named CUDNN64_7. So this is the CUDA Deep Neural Network library. So once again, just go, but again, pay attention to the library name that it loaded, make a CUDA folder. Then over here, I get the CUDA 7 to see everything so good. Now let's go into our Unity project. Over here I have a project that's pretty much just brand new, so just a simple demo I have prepared. The ML Engines package works with any Unity version starting from 2018.4. Now I want to make sure that this video stays relevant for as long as possible, so in this project I'm currently using 2020.2, but everything works exactly the same if you're using 2019.4 or if you're in the future using the 2020 LTS version. So to install the ML Agents package, just go ahead, open up the package manager. Then here, select the packages and make sure you go into the Unity registry. And in here, just scroll down and find the ML Agents package. Here you can see the latest stable package, which as of the time of this recording is version 1.0.6. And again, I want this video to be relevant for a long time, so I'm going to instead install the latest preview package. So for that, I'm going to click on the gear icon, go into the advanced project settings, and in here I'm going to enable the preview packages. And yep, I understand. So over here on ML Agents, I can expand it, see the other versions, and here I see the latest preview package, which as of the time of this recording is 1.6. But again, if you're in the production stage of your development and you want maximum stability, then go with the stable Unity LTS version as well as the stable ML Agents package. So select your choice and go ahead and click on install. Okay, it's done. And you can verify that everything installed correctly by just creating an empty game object. And over here, if you go into add component, you should be able to now see a group for the ML agents, and over here the various scripts. Alright, so we have everything correctly installed. Now over here for testing I have this demo, which is pretty much taken from the official examples. It's just a nice character, and over here is the goal. So the objective is to teach this character to move towards the goal and not fall off the map. So let's see how we actually use our ML agents. Now for that, first we need to create an agent. An agent is what's going to run our AI both for training and then for playing. And in order to make an agent, we just make a normal C# script. So just right click over here, go into create a new C# script, and let's name this the move to goal agent. And go ahead, open up of the script. And now in here we need to go up here to add using, go inside Unity, and let's use the Unity ML agents. Then over here let's get rid of the default methods, we don't need them right now, and instead of inheriting from model behavior, we're going to inherit from the agent class. So over here, you can right click on the agent and go into the definition. And here we see the definition of that class. So the agent and go into the definition. And here we see the definition of that class. So as you can see, we have a whole bunch of methods learning from its initial cycle. We need to override two functions. So we're going to need to override this one, collect observations, in order to give the agent some observations. And then we're also going to need to override this one, which receives a buffer with all of our actions. Okay, so let's go back into our script, so our move to goal agent. And first let's look at how the AI takes actions. So we're going to do a public override, and we're going to override the on action received, which takes an action buffer. So this buffer then contains our actions as either floats or ints. Now, one thing to keep in mind is that the machine learning algorithm only works with numbers, meaning that it doesn't have an understanding of what exactly is a player object or what it means to move to the right. All it knows is numbers. It's easier to understand this if we see it in action, so for now let's go back into the editor. And over here let's select our agent, so I have my nice agent in here, and I'm just going to drag the move to goal agent and attach it in there. And yep, here's our move to goal agent script. And when we added this, it also added the behavior parameter script. These are the various parameters that our AI uses. First, we have the behavior name, so let's rename this to move to goal. So give it a proper name to this agent. And then over here, let's look at the vector action. So let's learn what all of these mean. First of all, you've got the space type. So in here you can choose between discrete and continuous. Now essentially discrete are whole numbers, so you can have 0, 1, 2, 3 and so on. And continuous are floats, so going between -1 to +1 and all of the numbers in between. So 0.2, 0.3, -0.4, and so on. We're going to do a quick test to see these differences in a bit. Let's just learn about the other parameters. So first, if you select continuous, over here you see the space size, and this is how many actions you will get on the vector. So for example, if you put a 2 here, then in the code, if we inspect our action buffers, we see that this contains 2 action segments, one for the continuous actions and one for discrete actions. So the action segment here is essentially an array, so when you set the space size, you are defining the size for the array of the type that you select. So if you set a space size of 2, then this will have 2 positions with 2 values, a value on index 0 and another one on index 1. And then if you choose discrete, the size is the same, so it's how many values you get on that array. But then you also have this second parameter, which is the maximum value for this branch. So like I said, discrete means integers or whole numbers. So for example, if you put a 1 here, then you will get an action value of just 0. However, if you put a 2, then you're going to get an action value of either 0 or 1. And if you put a 5, then you can get a 0, 1, 2, 3, or 4. And each branch can have its own size. So for example, if you're making a car AI, you would make the first branch refer to accelerating and braking. So you would put it with 2 values. And then for the second branch, let's say it would represent turning, so you would put 3 values, one for turning left, turning right, and don't turn. Okay, now before we go further and look into how to define training, let's just test these actions to get a better understanding for how all of this works. So first let's put it at discrete with just one branch, keep it simple, and let's put it with a size of 5. And now over here in the code, we simply do a debug.log. We go inside the action buffers, then we access our discrete actions, and let's just print out what's on index 0. Since we have just one branch, that means we have one value on this array, so that value is on index 0. Okay, now before we can test this AI, we need to add one more thing. Over here in our agent, let's add the component, go into ML agents, and we're going to add a decision requester. Okay, so machine is going to go so numbers between 4 and so on. And this is in the code if we continuous actions, and when size you will have 2 positions. Choose this. Also have this integer in value or 1, and first then for the turning left, test these one branch log and value on this array. So that value is on index 0. Okay, now before we can test this AI, we need to add one more thing. Over here in our agent, let's add the component, go into ML agents, and we're going to add a decision requester. Like I said previously, the way reinforcement learning works in order to take every certain amount of time and then takes actions. Now there are other ways of requesting decisions, but for now let's just use this simple script. Okay, so over here we are ready to begin training and run our test to see what the AI will output over here. So for that, let's go back into our command prompt, and here make sure you are inside the virtual environment, and in order to train it, it's very easy. We just run the command ml-agents-learn. So just hit enter, and yep, we see a nice ASCII Unity logo and a message telling us that we can start training by pressing the play button. So just do that, just in here press the play button, and yep, we now have our training running. So we can check in the command prompt, yep, we have everything running. So it listens to that and it's running our training. And over here we can check on the console, and now we can verify and see what the actual action vector contains. So let's hit on collapse, and over here we can see that we put just one branch with a branch size of 5. So over here we do have values going from 0, 1, 2, 3, and 4. So we have 5 values, 0 to 4. So this is what it means to have a discrete vector with a branch size of 5. Now let's test with the continuous type to see what actions we get. So here let's just swap it from discrete into continuous, and with space size of just 1. Then here in the code it's pretty much the same. The only difference is we access the action segment for the continuous actions instead of discrete, and the position is the same on index 0. And now we want to run this test. So here in the command line, first of all, we can see that the previous test worked correctly. So we have our training, we have our model, and so on. And here, if we run the exact same command, ml-agents-learn, if we run it like this, there it is, we get an error. And the error is because we're trying to run training again on using the same default ID. So over here we have two options. We can call our ml-agents-learn with the force tag, so this will override the previous data, or we can specify a different ID name. So let's try doing that. So --run-id equals and then something name. So say test2. So now if we go ahead, hit on enter, and yep, we have it. We are listening on the port, so just start training. So just hit it and let's see. And yep, we have training running, and now we can see what this one does. So we can see what a continuous action looks like. So over here we are getting values pretty much between -1 and +1 and everything in between. Alright, so now you should have a better understanding of exactly how the actions work. So discrete is integers, and in continuous we've got floats from -1 to +1. So as you can see, these are really just numbers, so it's up to you to decide what they represent. Now let's look at another part of the reinforcement learning cycle. Let's look at observations. So back in the code here, the way we collect observations is by overriding a function. So we just do public override, and we're going to override this one, collect observations, which takes a vector sensor. And as soon as you do, up here it will add the using Unity ML agent sensors. So this is where this sensor exists. So we have our collect observations function. And now observations are how the agent observes its environment. So think of it kind of like the inputs for the AI. And obviously this will differ based on what problem you're trying to solve. So essentially you need to think about what data does the AI need in order to solve the problem you're giving it. Now our goal in this example is we have a character and we have a goal and we want to move the character towards the goal. So if you think about it, if you are controlling the player, so what information do you need? Well, first of all, obviously you need to know where you are, so we should pass in the player position. And then you also need to know where the target is, so we also need to pass in that position. So over here in the script, how we pass that into the AI is very simple. We just go into the sensor and call the function addObservation. And over here, first let's pass in the transform.position, so the player position. So with this, the AI will have the data for the player position. And then let's also pass in the target position. So up here, let's just add a serialized field for a reference. So a transform for the target transform. So back in the editor, for the target transform. So back in the editor, we have our field. Let's just drag the goal transform on there. And in here, we do the same thing, sensor, add an observation, and pass in the target transform position. All right, so we did these two positions. The AI should have enough data taken from observations of its environment in order to be able to complete its task. So we're passing in these two observations. And back in here, let's now look at the vector observation parameters. So we see a space size. So this is how many inputs we're going to give it. And back in our code, you might think that we're sending in 2 inputs. However, we're really sending in 2 positions. And you have to remember that a position is really a vector 3, which is composed of 3 floats for the x, y, and z. So for each of these 2 positions, each of them is passing in 3 values. So with 2 positions, we're actually passing in 6 values or 6 floats. So in here, for the space size of the observation, we're going to set it to 6. Then the other parameter is the sect vectors. So this is for more advanced use cases where you need the AI to have some sort of memory. So if you set it to 1, then it just takes 1 observation, grabs all of its 6 values and makes its decision. And if you set this to 2, then it takes 1 observation and also the last one and uses both of those to make its decision. So for example, if you pass a stacked vector of more than 1 and you use the position as the observation, then the AI could then infer the direction of the object. But like I said, that's for more advanced use cases, so here let's keep it simple and just put it at 1. Alright, so with this we have our observations taken care of, and we already saw how the actions work. So now let's actually use those actions. Again, the goal in this test is to move the character towards the goal. So for that, let's set the action space into continuous, so we have floats, and let's set it to receive 2. So we're going to receive one for the X movement of our character and another one for the Z movement. So back here in our code, let's grab our actions. We're going to define the first position as the X. So a float move X, we go into our actions. In this case, we're using continuous actions. So you grab
to the next line, we assume everything is continuing to work fine. We're going to set up a new stream reader. And then it's going to randomize the hue as we go. But yeah, it does look like...
That one on index 0, this will be our move X, and then the other one on index 1 is for the move Z.